Section 4.6 Variation of parameters. Consider a linear second-order differential equation in the form of a2y double prime plus a1y prime plus a0 times y equals g of x, and in the standard form as y double prime plus p times y prime plus q times y equals f of x, where p, q, and f are continuous on an interval I. Assumption: we are going to seek for the solution yp for the second-order differential equation in the form of yp equals u1 y1 plus u2 y2, where y1 and y2 are solutions of the complementary solution or the solution of the associated homogeneous equation. And the method that we are going to use in this section is called the method of variation of parameters. To solve a2 y double prime plus a1 y prime plus a0 times y equals g of x, first of all, or step 1, we are going to find the complementary solution yc equals c1 y1 plus c2 y2. And then step number 2, compute the Wronskian of y1 and y2, or w y1 and y2. And step number 3, dividing differential equation by a2 to get in the standard form as y double prime plus p times y prime plus q times y equals f of x. Step 4, find u1 and u2 by integrating u1 prime from w1 over w and u2 prime from w2 over w, where w1 is the discriminant of the metric 0, y2, f y2 prime, and the w2 is the discriminant of the metric y1 0, y1 prime, and the f of x. F of x is from the right-hand side of the standard form of the differential equation. And the last step, a particular solution yp is in the form of u1 times y1 plus u2 times y2, and the general solution of the differential equation is y equals yc plus yp. Let's look at the example. Example 1. Solve the given differential equations by the variation of parameters. Part A. Y double prime plus y equals secant x times tangent x. This is the non-homogeneous second-order linear differential equation, where the right-hand side, the gx, is in the term of secant x and tangent x. In this case, the undetermined coefficient cannot be applied. So step number 1, we are going to find the YC solution or the complementary solution from the associated homogeneous equation, which is y double prime plus y equals 0 and give us m squared plus 1 equals 0, or m equals 0 plus minus 1i. Therefore, the solution YC equals C1 times cosine x plus C2 times sine x, and that tells us the y1 equals cosine x and y2 equals sine x. Step number 2, we're going to find the Wronskian of the y1 and y2, which are solutions of the associated homogeneous equation, or we are going to find the Wronskian of cosine x and sine x. And the Wronskian is the determinant of the 2x2 matrix for this case. The first row, cosine x, sine x, which are the y1 and y2. And the second row is the derivative of the function y1 and y2, which is negative sine x for the first column and cosine x for the second column. The determinant is using the Cramer's rule. Crossway down and crossway up. With a crossway down, we get cosine times cosine, which is cosine square of x, and then minus negative sine times sine, which is plus sine squared. And the result is 1 as a W of y1 and y2. And then step number 3, we are going to write the equation in the standard form. If it's not in that form yet, for this problem, it's already in the standard form because the coefficient of the highest order is 1. So y double prime plus y equals secant x tangent x. From the standard form, we get the f of x, which is the function on the right side of the equation. So f of x equals the secant x times tangent x. Next step, we're going to find the Wronskian 1 and Wronskian 2. So the Wronskian number 1 is the determinant of the first row going to be 0, and the second row of the first column going to be f of x, and then the second column going to be y2 and y2 prime. Replace it, since the f of x is the secant x tangent x, the y2 is sine x, the derivative is cosine x, and the determinant, use the Cramer's rule. Crossway down, the 0, crossway up, it's going to be sine negative sine x times secant x times tangent x. And then simplify this product of the trig functions to be negative sine x times 1 over cosine x times tangent x. It looks like we have negative tangent square x for the W1. And then find W2 similar way, but this time the first column is y1 and y1 prime. Second column is 0, f of x, or the determinant of cosine x, 0, minus sine x, the f of x, which is the secant x tangent x. Use the Cramer rule, we get cosine x multiplied by secant x times tangent x, and simplify this trig product to get cosine x and 1 over cosine x reduced, and that return the tangent x. Therefore, the W2 or the Wronskian 2 is the tangent x. And then step number 4, we are going to solve for U1 and U2. From U1 prime is W1 over W. And the W1 that we found is negative the tangent square x divided by the W, which is 1. And then we're going to find U1 by finding the antiderivative of the negative tangent square over 1 is just the same expression. So the integral of the negative tangent squared, we rewrite it as negative integral of the secant square x minus 1 by using the trig identity. So integral of secant squared is the tangent x, and then integral of negative 1 with respect to x is negative x. That becomes plus x. So we get U1 as negative tangent x plus x. And next we're going to find U2 prime. U2 prime is W2 divided by W. W2 is the tangent x and divided by the Wronskian, which is 1. Now U2 is the antiderivative of the tangent x with respect to x. And the integral of the tangent, which is the integral of the sine x over cosine x with respect to x. Use the u sub technique by letting u be cosine x. So we get integral negative 1 over u, which is negative natural log of the u. So negative natural log absolute value of the u, which is cosine of x. Ignore the constant of integration. Now we get both u1 and u2. The last step, or step 5, the particular solution yp is in the form of u1 times y1 plus u2 times y2. And recall the y1 is cosine x and y2 is sine x. u1 and u2 we just obtained from finding the antiderivative of the u1 prime and u2 prime. So the u1, which is negative tangent x plus x, multiplied by y1, which is cosine x, plus the u2, which is negative of natural log, the absolute value of cosine x, times the y2, which is sine x.